Hey, so I'm just going to give a couple minutes when people are getting logged on. We're going to get ready to go over our Go Math homework, lesson 7.7, page 157. Coming to you live from the bathroom. Again, it's quiet though. And it's got good lighting, to be honest. Good lighting, it's got good sound, it's a good place to be. I'm just saying. All right, so I'm going to go ahead and get started. For those people who are joining later, I'm going to actually preview something else that I did not sign as homework. Hey guys, I see everybody getting logged on. Awesome. So as you're getting logged on, what I was just going to preview with you is what is happening here. That we have used the area model before to multiply, and they're doing it in this instance as well. So they're multiplying here 2 1/4 times 1 1/2. So what you can see that they did is when they multiplied this, they did 1 1/2. They used 4 as the whole, like common denominator. So 1, 2, 3, 4, that's 1. And then these next two is 1/4, 2/4. There's your half. So 1 1/2. And then we multiplied that by 2 1/4. So they did 2 wholes. So 1/4, 2/4, 3/4, 4/4 is 1 whole. 1/4, 2/4, 3/4, 4/4 is your whole. And then 1/4 was left over. So if you wanted to use an area model, basically what you, hey, I'm just doing a preview for this, friends getting logged on. Basically what you do if you're doing an area model is much like what we've been doing. Who's not going to be at school tomorrow? Who is that? I don't know all these usernames. Is you break it down by the value of each digit. So we broke it down by here's 1 whole and here's 1/2. Then I broke it down here by here's 2 whole and here's 1/4. So I can cross multiply. 2 times 1 is 2. And then 2 times 1/2 is 2 times 1/2 is equal to 2 whole. Whoops, this was 2 whole. Sorry. Wow, that was a miss. There's your 2 whole. There's your 2 there. And then, no, Jesus, is 2 over 2. Hi, Brayden. Brayden. I don't know who that is. It's 2 over 2. And then 1/4 times 1 is 1/4. And 1/4 times 1/2 would be 1/8. And you can add all those together. We didn't do that in class. I'm not even going to do that. So let's move on. Let's go here. So what we did today in class is we said that we can multiply by turning these into improper fractions. So you can do your whole number times your denominator and then join it in with your numerator. So if I did 1 times 8, that would be 8 eighths. 1 times 8 is 8. Add it with numerator. You would get 8 eighths is your 1 whole plus 1/8 that you already had. You would add those two together and then multiply it by 2 1/2. So same thing again. Whole number times your numerator. So 2 times 2 is 4. 4/2 is equivalent to 2 whole. And then you're adding it in with the 1/2 that you already have. Now we've done a simplified version where we've skipped this whole step of doing this, but I'm just trying to make sure that you understand like the why. So whole number times your numerator, add it to whole number times your denominator, added to your numerator, you would have 9 eighths. Because again, 1 times 8 is 8, plus the one that you already had, now you have 9 eighths. And then the same thing here, we did our whole number times our denominator and we got 4. We added it with our numerator of 1/2, and now we have 5/2. Whoops, I put an add sign there and it's multiplying. And now I can just multiply it like I would multiply a normal fraction. Numerator times my numerator. 9 times 5 is 45. And denominator times my denominator, 8 times 2 is 16. So then I can just regroup this. How many times can 16 go into 45? If I know my multiples of 15, I know that 15 times 3 is 45. And since this is more than 15, I know it can't go in 3 times. It's a little bit too much. It could only go in 2 times. And if you think about it, 2 times 16 means I'm taking away 32. 16ths. So 45 minus 32, if you needed to rewrite it going up and down, you could. 45 minus 32 is 13. So what I'm left with is 2 and 13/16. This is an acceptable answer. Good job, Epic Gamer X. And this is also acceptable because they are, sorry, they are equivalent. They have the same value. Hey, I thought that was Guido, but I didn't want to call that. Yep. Guido, I'm glad that you're on catching up, hopefully, so that you don't miss out on too much. So we're going to do the next one again. I can take these and turn these into improper fractions and then multiply. So to turn them into improper, it's whole number times your denominator, and you're adding it into your numerator. So 2 times 3 is 6. So you're adding in 6/3. 2/3 plus 6/3 means you now have 8/3. Same thing here. Take it, turn it into improper. Whole number times your denominator, add it into your numerator. 1 times 3 is 3. So I'm adding in 3/3. 1/3 plus 3/3 means I now have 4/3. And then I just multiply it, standard algorithm, right on across. Whole number times your whole number. Numerator times your numerator. Denominator times your denominator. So I already have one acceptable answer right there. I can express it as an improper fraction, or I can create an equivalent fraction and regroup it into a mixed number. So 9 can go into 32 how many times? Let me think. I know my 9s. 9, 18, 27, 36. Oh, 36 is too high. So it cannot go in 4 times. It can go in 3 times because 3 times 9 means I'm taking away 27 ninths, because 27 divided by 9 would be the 3 whole. So take away 27. 32, take away 27. And again, I can rewrite it going up and down. So I'm going to give you a minute to take a moment and subtract 32, take away 27. Shall we says? Does anybody have any answers? Well, I know that 2 take away 7 I cannot do, so I would have borrowed from the 3 and turned it into a 2. And then I would have done 12 take away 7 is 5. 2 take away 2 leaves you with nothing. So therefore, 32 take away 27 is 5. I could have also started at 27 and counted on to 32, 27, 28, 29, 30, 31, 32. I counted on 5 times. And your denominator would stay the same. So you have, essentially, you have 2 answers. You have 32 ninths and you have 3 and 5 ninths. These are equivalent. On a select all, they could both work. On a multiple choice, it might only have one way listed. So you really have to be fluent with taking both ways, improper and mixed. And then our final question for the night, again, whole number times your denominator. Add it into your numerator. So 1 times 4 is 4. So you're basically going to add in 4 fourths with your 3/4. So you're getting rid of that. Whole number times your denominator, you're adding it in. I now have 7/4 times, same thing here, whole number times your denominator, adding it into your numerator. So 2 times 2 means I'm adding 4 halves. I'm adding 2 times 2, I'm adding 4 in. The denominator is going to end up staying the same. So 1/2 plus 4 halves means I now have 5 halves. And then again, numerator times your numerator, denominator times your denominator. So 7 times 5 is 35. And so 4 times 2 is 8. Boom, I have an acceptable answer. However, again, I need to be fluent going both ways, so I can take my improper and I can also express it as a mixed number. 8 can go into 35 how many times? Let's see. I count by faith. 8, 16. Oh, I can still do more. After 16 is 24. I can still do more. After 24 is 32. After 32 is 40. Oh, 40 is too high, so I can't do 40. So let's see. 8 went into 35. 1, 2, 3, 4 times. So I'm able to make 4 whole because 4 times 8 means I'm taking away 32 eighths. And again, 32 divided by 8 is 4. That's where my 4 whole is coming from. So 35, taking away the 32 that I've just used to regroup. 35 eighths minus 32 eighths is 3 eighths. So there, you have another acceptable answer. Both of those are correct and will work. Any friend who is watching this video and decides to do number 3, no, sorry, that's not 3, number 6 and number 7, I would love for you to do number 6 and number 7. If you try number 6 and number 7 tonight on your own, I will add on 5 extra bonus points to your test to help bring up your average. If you need help, feel free to comment. I will be glad to help you. Otherwise, have a great night. Enjoy your math. Rock on.